So this is part 2 of the area past paper question solution video. Alright, so we're on to question number 3. A new hotel is being planned in Benidorm. The pool will have a walkway around 3 sides. The walkway will be 1.5 metres wide. This is shown in the diagram. Calculate the total area of the walkway. So again, this is kind of one of those questions where you've got an outer area and you maybe want to subtract the inner area. Alright, that's maybe what you see first. There is also a couple other ways that you can maybe go about it. But basically what we want to do is work out the area of this white bit. So you can hopefully kind of see, imagine you've got the big outer rectangle with that rectangle cut out of it. Alright, that's kind of as easy as that, and it's probably the first thing that people would visualise. So this is a paper 2, so it's a calculator 1 as well. Right, so I'm just going to work out the area for the outer shape first, and then work out the area for the inner shape. So for the outer, I'm obviously going to need a length and a breadth. So let's see if I can work out what the length is. Well, it's 16 metres from here to here, and it's 1.5 metres all the, from there to there. So in total, that's obviously going to be 17.5, just adding those together. Alright, so that continues on, and then that makes that 17.5. And then the breadth of the outer one, well, this is 8 metres, but obviously I have got this little extra bit added on here, and this extra bit added on here. They're 1.5, so that then means that I'm doing 8 plus 3. Okay, 1.5 plus 1.5, that would be 11. So that's the area of the outer. So calculator, 17.5 times 11, and it's 192.5, and it'll be square metres. Okay, so that's the area of the outer shape. The area for the inner, so that's that shaded part that is not going to be, that's not part of the path. That's the pool itself. Alright, so it's 16 metres by 8 metres. 16 by 8. And that's 128 square metres. So then to work out the area for the path, that's going to be nice and easy. That's just going to be the outer, take away that shaded inner area. And that is 64.5. Now, just to kind of point out to you, there would maybe be other ways of doing it. I could probably split this up into that length there, and that length, that part there. Right, I probably could do that, and I'm sure that it's possible to do it like that and add up the area for those 3 sections. But probably what you'll get used to, and what you would then see first looking at a question like this, is outer area take away the inner area. Alright, so question number 4. A garden is in the shape of a right angled triangle. It has a semicircular pond on the hypotenuse as shown. Part A says calculate the diameter of the pond. This is a paper 2, so it's calculator. So I'm wanting to work out what the diameter of the pond is, so it's this length here. Now obviously I've got my right angled triangle, and what I'm going to need to be able to work out the diameter of the pond is I'm going to need to know what the length of this full side is. So I've got a right angled triangle, missing side, that's Pythagoras. So this is my triangle. I know that this is 20, this is 15, and I'm wanting to work out this. So label your triangle, C, A, B, C squared equals A squared plus B squared. So C squared is going to be 15 squared plus 20 squared. Grab a calculator, get an answer. 15 squared plus 20 squared, 625. Then take the square root of that. So the square root of 625, that's actually 25. And it is metres. So this part here all the way from one end to the other is 25. Obviously, if that's 8 and 8, then I'm really doing taking off the 16. So that then means that this is 9. So for part A, the diameter is equal to 9 metres. Okay, part B says the garden, excluding the pond, is to be covered with stone chips. Calculate the area to be covered. So again, this is that type of question. You start off with a shape, the triangle, and that pond is getting cut out of it. So we need to work out the area for the triangle, the area for the circle, and then subtract that off. So let's work out the area for the triangle. This is part B. And that is a half of base times height. The height is 15, the base is 20. So the area then for that outer triangle is 150 square metres. And we need to now work out the area for the circle. If the diameter is 9, the radius is obviously half of that. So that's something we need to make sure that we do. Area of a circle, it's a half circle as well. So I'm going to be using pi r squared, but I'm obviously going to divide by 2. The radius is 9 over 2, so that means it's 4.5. Plug our values in, pi r squared, so 4.5 squared, divide by 2. Grab the calculator, put that in. So it's pi times 4.5 squared, and then half that. That's getting me 31.8, and I'm just going to round that to 2 decimal places, so it'll be 1. Okay, I'm just saving space, that's why I'm not rounding. So that is square metres. And then, just a reminder, we're working out the area that's getting covered in stone chips, so that is everything excluding the pond. So let's just say the area that's being covered is the area for the triangle, which was 150, I think. Yep. Take away that area for the circle, 31.81. So 150 take away 31.81, and we're left with 118.19 metres squared, square metres. And that's us for part B. Then part C says the stone chips come in 25 kilogram bags, costing £2.59 each. 1,000 kilograms of chips covers an area of 20 metres squared. Calculate the cost of the stone chips for the garden. Well, what I need to kind of work out then, so 20 metres squared requires 100 kilograms worth of chips. So how many bags am I going to need? So to work out how many bags I'm going to need, hopefully you can kind of see, you could just count up in 20s. But what you could do is you could divide by 20. So that's the amount that we need. How many 20s would I need? Well, it obviously says 5.9 and so on, but that then means that I need 6 bags. But hopefully you could just see that 6 times 20 is 120. Okay, so 6 bags are needed. Or rather, 6 lots of 1,000 are needed. Okay, so I will correct that. So it's 6 times 1,000 kg that's needed. So I need 6,000 kilograms, and each of them is 25 kilograms. That's what each bag is. Okay, so I've got 6,000 kilograms that's needed, and then number of bags. This is part C. Number of bags is just going to be 6,000 divided by 25. And that's 240. So that means that the cost is just going to be 240 times, I believe, I want to say 599, nope, 259. So 259 and then the price then is £621.60, and that's the final answer for that one. Okay, so again, that one's quite a nice question because it leads you into all those different steps. Alright, it kind of leads you in. It doesn't just ask you part C at the end and expect you to be able to do those. It leads you in with part A, part B and part C. Question number 5. Anissa makes enamel badges. Each badge is made from metal. The shape of the badge is shown below. Calculate the area of the front of the badge. Well, I've obviously got two shapes here. They're both identical. So really, if I work out the area of one, I can then get the area of the other. So, hopefully you can see here, I have got a triangle and a rectangle. Let's work out the area for each one. Okay, I just like to label them. The area for the triangle is a half of base times height. The base, well, that's going to be 4 centimetres. Okay, hopefully you can see that. If it was 8 from one side to the other, halfway is going to be 4. And then the height, well, if it's 2 centimetres up here and 3 centimetres up here, this must be just 1. So it's half of 2 times 4, sorry, half of 4 times 1. Half of 4 is just 2 times half of 1, so that would be 2. Okay, so a half of that would just be 2. Again, it is paper 1, so make sure that for this one, that is pretty straightforward. Don't need a calculator for that, and indeed you're not allowed a calculator for that. So that's 2 square centimetres. Then the area for the rectangle, well, that's length times breadth. It was 4 centimetres in length, and the height is 2. So that's just 8 squared centimetres. So obviously it's 8 plus 2, right? So the total area is just going to be 2 plus 8, and that's for one side, and then I'm obviously timesing it by 2. So that's just going to work out as 20. Alright, that's the area for the front of that badge. Question number 6, on to another longer-winded one. A new playground is planned for primary school. It will be a rectangle measuring 19 metres by 8 metres. A semicircular sandpit will be built within the playground as shown. So that here is going to be our sandpit. The playground, excluding the sandpit, is to be covered in rubber tiles. Calculate the area to be covered. We have got to use 3.14 because this is a non-calc paper. So remember, this is that type of question again. Then we've got some area and then a part's been removed. In this case, it's that sandpit. So I'm going to work out the outer area, take off the inner area, and then that'll be my answer. So let's work out the area for that outer rectangle. Dead straightforward. 19 by 8. So 19 times 8. If you need to do a sum, then that's fine. 8 times 9 is 72. 8 times 1 is 8. Add those two together. That's going to be 15. Okay, so it's 152. And it is square metres. Then the area for the half circle. Well, what's my formula? It's pi r squared. And then I'm obviously going to half it. Let's take a look at working out what the diameter or even the radius of this is going to be. Well, from here to here first. Let's work out the diameter first. Well, if it's 8 metres here, but the space, kind of the gap between the sandpit and the outer edge, is 1 metre each side, that must mean that this bit in here is 6. Okay, and then the radius is obviously going to be 3, but we'll put that down. So the radius is going to be 6 over 2, which is 3. So it's going to be pi is actually 3.14 times, and it would be 3 squared, and then I'm halving it because it's a semicircle. So it would be 3.14 times 9, and then I'm dividing that by 2. So let's do the 3.14 times 9 over at the side. Line up decimal point. 4 times 9 is 36. 9 times 1 is just 9 plus 3 would be 12. 3 times 9 is 27, so it would be 28. So yep, 28.26. And now I'm dividing that by 2, so I can go and do that at the side somewhere as well. So 28.26, divide that by 2. Okay, and that one actually could have been done non-calc, right? You could just half that, dead easy. So 14.13, and it's again square metres. So that's me got the area of the outer, the area of the inner, and now to work out the area that's going to be covered, I'm just going to do the outer, which is 152, take away that sandpit area that's not included. If you need to do a sum, you can do that. So 152, and it's 14.13. I would add in 2 zeros there. Okay, can't do that, need to borrow. So that would become 1, can't do that, need to borrow over here. 10 take away 3 would be 7, 9 take away 1 would be 8, can't do that, need to borrow. 11 take away 4 would be 7, 3 and 1. Okay, and I'm just doing a wee quick check. Yep, that is correct. Okay, so that's our answer there. And it's square metres, and that's the amount that is getting covered. Okay, because the sandpit is included. However, right down the bottom there it says round your answer to 3 significant figures. So let's just make sure that we do that just now. I'm just going to get rid of that line. 3 significant figures, 1, 2, 3. So it's here that I'm drawing the line. If it's 8, that means it's going to round up. So it'll be 139 square metres. And that's it rounded to 3 significant figures. So quite a kind of common theme with the area questions. Often you've got some part cut out or some part that's not being covered. So you're doing quite a similar thing for these area questions. Work out the area of the outside and then work out the area of the inside and then subtract. Something else that comes up a couple of times there is a wee bit of Pythagoras, because you might be dealing with right angled triangles, area of right angled triangles and so on. Make sure that when you're looking at area you're comfortable with knowing your formulas. You will get given the area of a circle formula, but you'll need to know the triangle and the formula for a rectangle and a square as well. So just make sure you're comfortable with those. Also with area, just like volume, make sure you're including squared units whenever you're talking about area. So remember, this is part 2 of a two-part video, so make sure that you've watched part 1 as well if you're trying to go over these questions.